Hi, hello there. Welcome to IP static routing. There are so many different ways to dynamically route a packet that you might wonder why anybody would take time to manually configure a static route. It is kind of like hand washing all your clothes when you have perfectly good washing machine. But you know that some clothing items cannot go in the washing machine. Some items benefit from being washed by hand. There is a similarity in networking. As it turns out, there are many situations where a manually configured static route is your best option. There are different kinds of static routes, and each is perfect for solving or avoiding a specific type of network problem. So many networks use both dynamic and static routing. So network administrators need to know how to configure, verify, and troubleshoot static routes. You are taking this course because you want to become a network administrator. Or maybe you want to improve your existing network administrator skills. So you will be glad you took this module because you will use these skills frequently. And because this module is about configuring static routes, there will be a demo video associated with this. Now, the module title is IP static routing. And at the end of this module or video lecture, you should be able to configure IPv4 and IPv6 static routes. Also, part of this video lecture are discussions on static routes, configure IP static routes, configure IP default static routes, configure floating static routes, and configure static host routes. This video lecture is associated with a video demo on how to configure IP static routing. Okay, so let's begin with the first section, static routes. Okay, so types of static routes. So static routes are commonly implemented on network. This is true even when there is a dynamic routing protocol configured. For instance, an organization could configure a default static route to the service provider and advertise this route to other corporate routers using the dynamic routing protocols. So static routes can be configured for IPv4 and IPv6. Okay, so both protocols support the following types of static routes. So you've got the standard static route, default static route, floating static route, and summary static route. The static routes are configured using the IP route command and IPv6 route global configuration commands. Okay, so the next one would be the next hop options. So when configuring a static route, the next hop can be identified by an IP address, exit interface, or both. So how the destination is specified creates one of the three of the following types of static route. So the first one would be your first or the next hop route. Okay, only the next hop IP address is specified. You also have the directly connected static routes. So only the router exit interface is specified. And then the third one is the fully specified static route. So the next hop IP address and the exit interface are specified. Okay, so the IPv4 static route command. So IPv4 static routes are configured using the following global configuration command. So this is the syntax whenever you want to configure a static routing or your router. Okay, so that would be on the global config, you have to type in IP route followed by the network address, okay, subnet mask, IP address, exit interface, IP address, and the optional distance. So either the IP address or the exit interface or the IP address and the exit interface parameters must be configured. All right. Now, what are these parameters that we have here? So again, the syntax would be IP route. So what is this network address? The network address identifies the destination IPv4 network address of the remote network to add to the routing table. So the next one would be subnet mask. So it identifies the subnet mask of the remote network. So the subnet mask can be modified to summarize a group of networks and create a summary static route. So the next one would be an IP address. It identifies the next hop router IPv4 address. So typically used with broadcast networks like the Ethernet. Okay? It could also create a recursive static route when the router performs an additional lookup to find the exit interface. Next would be the exit interface. Okay? So it identifies the exit interface to forward packets. So it creates a directly connected static route, typically used in a point-to-point configuration. Okay? So next would be the exit interface IP address. It creates a fully specified static route because it specifies the exit interface and the next hop IPv4 address. Now, distance here is optional command that can be used to assign an administrative distance value from 1 to 255. So typically used to configure a floating static route by setting an administrative distance that is higher than a dynamically learned route. Okay, so now that you know the syntax on how to use IP route, now you can go ahead and configure it. Okay, give it a try on the packet tracer. Now on the IPv6 static route command, so this would be the syntax. So it's almost the same. All right. So the syntax would be IPv6 route, okay, IPv6 prefix or the prefix length, IPv6 address, exit interface or the IPv6 address, and the distance. Okay. Now similar with IPv4. So let's start with the IPv6 prefix or the prefix length. Okay. So for the IPv6 prefix, it identifies the destination IPv6 network address of the remote network to add to the routing table. Now, the prefix length, it identifies the prefix length of the remote network. Next would be IPv6 address. It identifies the next hop router IPv6 address. So this is typically used when broadcast networks like the Ethernet. So could create a recursive static route where the router performs an additional lookup to find the exit interface, similar with that of the IPv4. You also have the exit interface here. It identifies the exit interface to forward packets, and it creates a directly connected static route. So typically, this is used in a point-to-point configuration. All right. So you also have the exit interface, okay, IPv6 address. It creates a fully specified static route because it specifies the exit interface and the next hop IPv6 address. Now you also have distance on IPv6. Okay, so this is also optional command that can be used to assign an administrative distance value from 1 to 255. So typically, this is used to configure a floating static route by setting an administrative distance that is higher than the dynamically learned route. Okay, so take note that the IPv6 unicast routing global configuration command must be configured to enable the router to forward IPv6 packet. All right, so most of the parameters are identical with that of IPv4. It's just that you have to include v6, okay, on the IPv6 route command versus that of IPv4, which is simply an IP route command. All right, so we will be using this even on my demonstration. Okay, so this topology is what you call a dual stack topology. So this figure shows a dual stack network topology. So currently, no static routes are configured for either IPv4 or IPv6. Okay, so this is the same topology that I'm going to use on demonstrating how to configure IP static routing. All right, So you've got here 3 router configurations. You've got a combinations of IPv4 and IPv6 addressing. Also, please see the video demonstration about how to configure the IP static routing. Okay, so IPv4 starting routing tables. So each router has entry only for directly connected networks and associated local addresses. Okay, so R1 can ping R2. Okay, on this demonstration. Now going back to our topology. All right, so this is the topology that we're going to use on the demonstration. Now for the sake of video lecture, okay, so assuming that this has been configured completely with IP static routing, okay, and we are about to ping, okay, so from R1 to R2, which are directly connected to each other. Okay, so none of the routers have knowledge of any networks beyond the directly connected interfaces. So this means each router can only reach directly connected networks. So as demonstrated in the following ping tests, a ping from R1 to the serial interface serial 010 of R2 should be successful. Okay, so that would be because it is a directly connected networks. All right, so again, going back to the topology, on R1, we are pinging 172.16.2.2. And 172.16.2.2 is this interface here. Okay, so which is the interface of R2, pinging from PC1. Okay, so we can ping that because that is directly connected on R1. But a ping on 3, okay, or a ping on router 3 LAN is not possible. Okay, so from the topology, 192.168.2.1, okay, is the LAN of R3 here. And pinging from PC1 would lead to request timeout. All right, so because router 1 is not aware about R3. Okay, so that is because we have not configured yet the routing protocol. Okay. Next, how about R2 IPv4 routing table? Now, looking at the R2 IPv4 routing table, if you will observe here, all it displays are the directly connected networks. So C here indicates directly connected networks, whereas L, these are the IP address configured on the specific interface. Now, evaluating the routing table, okay, so we can see that on R2, okay, going back on R2, we can see 3 directly connected networks. So these are 172.16.0, 192.168.1.0, and 172.16.1.0 here. So if you try to look at the routing table, okay, so for R2, it shows 3 Cs here, right? So 172.168.1.0, 2.0, and 192.168.1.0. So all of it are directly connected to R2. All right. Now also on R3, okay, it only shows or displays directly connected networks to R3. And if you'll observe, you have 2 directly connected networks to it. And these are 192.168.1.0 and 192.168.2.0. Now referring that to the topology, okay, so it's in here, R3, you've got directly connected networks 192.168.1.0 and 192.168.2.0 here. Okay, so initially, after the configurations of the IP addresses on the interfaces and without the IP static routing, okay, so we can only see a directly connected networks on the routing table. All right. Okay, so each router has an entries only for directly connected networks and associated local addresses. So that is denoted by L. Now, same thing with IPv4. Now, this time, this has been configured with IPv6 IP addresses. Okay, so as usual, R1 can ping R2, okay, because they are directly connected, but R1 cannot ping the R3 LAN. Okay, so pinging R1 or pinging R3 from the R1 is not possible. That is because R1 does not have an entry in its routing table for that network. All right, so again, this will be shown on the demonstration associated with this video lecture. Next, you also have the R2 IPv6 routing table. Again, if you will observe, same thing. We have 3 directly connected networks and no remote networks yet defined on the routing table. So it's impossible for R2 directly connected devices to reach any of the remote network directly connected devices, okay, on the other routers. Okay, now this is the router 3 IPv6 routing table. Again, you'll see here directly connected networks. Okay, so that is 2001 DB8 Cafe 1 and Cafe 2. Okay, now that we're done with the basics of static or IP static routing, let's go ahead and see configuring IP static routes on this section. Okay, so let's talk about the IPv4 next hop static route. So the commands to configure the standard static routes vary slightly between IPv4 and IPv6. So this topic shows how to configure the standard next hop directly connected and the fully specified static routes for both IPv4 and IPv6. Okay, now in a next hop static route, only the next hop IP address is specified. The exit interface is derived from the next hop. For example, 3 next hop IPv4 static routes are configured on R1 using the IP address of the next hop of R2. Okay, now referring to the topology that we have earlier. Okay, so if I am on R1, the first thing that you need to do is to identify the directly connected networks to R1. Okay, and from here, the directly connected networks from R1 would be the 3.0 here and the 2.0 of 172.16. Okay, so identifying the directly connected networks will leave 172.16.1.0, 192.168.1.0, and 192.168.2.0 be the remote networks. Now, in configuring the IP static routing, we care only about the remote networks. So when we define it, we defined the remote networks. So if you will observe on this configuration here for R1, the remote networks would be 172.16.1.0. Okay, so which is this network here. All right. So to define it, so it should be IP route 172.16.1.0. That's slash 24, so that would be 255.255.255.0. Now, the next one would be the next hop IP address. So if I am from, let me change my pointer here. So if I am from R1, okay, this is me, the next hop IP address to reach the remote network is this. All right, and that is 172.16.2.2. That's why you'll have it here. All right. So to reach 172.16.1.0, 192.168.1.0, and 192.168.2.0, you need to pass through 172.16.2.2 as the next hop IP address. So all of this here would be the next hop IP address of the remote networks. So that is why on the configuration, you're gonna have here IP route 172.16.1.0, subnet mask, which is 255.255.255.0, and you're gonna have here the exit interface. All right. So same thing with the second remote network, which is IP route 192.168.1.0. So you've got 255.255.255.0 via 172.16.2.2. So the third remote network is 192.168.2.0 here. So defining it on R1, that would be IP route 192.168.2.0 255.255.255.0 via the next hop IP address, which is 172.16.2.2. All right. Now, after the configuration, so you might want to check the entry, okay, or the routing table entries on R1, and that would be possible via show IP route, okay, or you could have the option or the more specific show IP route pipeline begin gateway. So that means that would start with the word gateway here. Now, from the routing table, we could see that the remote networks that we have defined here is denoted by S on the routing table. All right. So you've got 1.0, 192.168.1.0, and 192.168.2.0. These three here are the remote networks that we defined on the configuration using IP route. All right. So aside from the directly connected networks, which is automatically detected by R1, since we already have defined the remote networks using IP route, so we can see here all the remote networks and the directly connected networks to R1. All right. Okay, so how about the IPv6 next hop static route? So it works the same with that of IPv4. Okay, so again, considering this topology here, so the commands to configure R1 with the IPv6 static routes to the three remote networks are as follows. So again, we have to identify. So we are from R1. This is where we're going to configure the IP route. We first need to identify the remote networks. And the remote network should be, this is your first remote network, your second remote network, and your third remote network. All right. So when we define it, so in IPv6, we have to use IPv6 unicast routing. So every time you configure a router for IPv6, so you need to start or initialize IPv6 unicast routing. Don't forget this, otherwise you won't be able to configure any IPv6 configuration commands on a router. Okay, so we need to start or to begin with IPv6 unicast routing. So afterwards, we can now do the routing. Now, assuming that we have already configured all the IP addresses on each of the interfaces with IPv6, we can now proceed with routing. All right, so the syntax, which was shown earlier, would be IPv6, all right, and then route. This is your remote network, which is 2001 DB8 ACAD 1/64. Okay, so that's on R1, right? Okay, so this is the first remote network, and still this is our exit interface. Okay, so therefore, from R1 to reach 172.16.1.0/24, we need to pass through 2001 DB8 ACAD 2. Right? So this would be our exit interface. If you will observe, that is common to all the remote networks. Okay, so we need to pass through this to reach remote networks 1, 2, and 3. Okay, now let us define the second network. So that would be IPv6 route 2001 DB8 cafe :1::/64 via 2001 DB8 ACAD 2. Right, that 2. And then let us define also the last one, which is the third remote network from R1. So that would be IPv6 route 2001 DB8 cafe 2, okay, ::/64, traversing via 2001 DB8 ACAD 2 colon colon 2. Okay, so after defining this route, so you might want to visit the routing table. So the command would be show IPv6 routes. And if you will observe here, we already have seen the 3 remote networks we just recently defined using the IPv6 route command. All right. Okay, so next would be the IPv4 directly connected static route. Okay, so when configuring a static route, another option is to use the exit interface to specify the next hop address. So the figure shows the topology again that we used on the demonstration. All right, so the IPv4 routing table for R1 shows that when a packet is destined for 192.168.2.0 network, which is denoted by S here, right? So this means this is a remote network. Okay, so R1 looks for a match in the routing table and finds that it can forward a packet out of serial 010 interface. So take note that this is your exit interface here. Okay, note that using a next hop address is generally recommended. Okay, what we did earlier, we use the next hop IP address instead of the exit interface. All right, so take note, this is a very important note here. So using the next hop address is generally recommended. Directly connected static routes should only be used with a point-to-point serial interfaces, as in this example. So take note that we can use exit interface here because we only have point-to-point connection here. Okay, whenever we connected routers using the serial interfaces, we could make use of the exit interface. All right, now let us evaluate this. This is the same configurations that we made using the next hop IP address. The only difference is with this one, we use the exit interface. All right, so how are we going to use this? Where is the exit interface? Okay, if I am referring to R1, for instance, we are viewing it in the perspective of R1. Okay, so 192 or 172.16.2.2 here would be our next hop IP address. And when you say exit interface, we are pertaining to this. All right, so from the perspective of R1, we can leave the networks of R1 via serial 010 here. So that is why in here, you've got serial 010. Now, to reach the remote networks like 172.16.1.0, okay, we need to use serial 010 as the exit interface. Same thing, to reach the remote networks 192.168.1.0, right, we have to use also the serial 010 as the exit interface. That also applies to remote networks 192.168.2.0 using the serial 010 exit interface. All right, so again, this is the second method of defining static IP routing. So it's either you use the next hop IP address or the exit interface. But the use of the exit interface is applicable only when you are using serial connections between these routers. All right, or when you have a point-to-point connection only between the two routers. All right. All right, so now you might be asking, is that also applicable on IPv6? Yes. Okay, so the IPv6 routing table for R1, okay, in the example, okay, shows that when a packet is destined for 2001 Cafe 2/64, so this is the S here, this is what we're pertaining to. Okay, so R1 looks for a match in the routing table and finds that it can forward the packet out of the serial 010 here, which is denoted by directly connected, this one. Okay, so take note, same with IPv4, using the next hop IP address is generally recommended. Directly connected static routes should only be used only when you use the point-to-point connection or when you use serial interfaces between two routers. Okay, so it's the same thing. So IPv6 route, this is your remote network 1, okay, and this is our exit interface here. So remote network 2, all right, and then the exit interface, and then remote network 3, and then the exit interface. All right. Okay, so the third one would be IPv4 fully specified static route. So in a fully specified static route, both the exit interface and the next hop IP address are specified. So this form of static route is used when the exit interface is a multi-access interface and it is necessary to explicitly identify the next hop. So the next hop must be directly connected to the specified exit interface. So using an exit interface is optional. However, it is necessary to use the next hop address. All right. So suppose that the network link between R1 and R2 is an Ethernet link, and that the Giga Ethernet 001 interface of R1 is connected to the network as shown in the figure here. Okay. The difference between an Ethernet multi-access network and a point-to-point serial network is that a point-to-point serial network has only one other device on the network. Okay, so this is a point-to-point serial network here. And this one here, okay, so this is the Ethernet link. Okay? So with the Ethernet networks, there may be different devices sharing the same multi-access network, including hosts or even multiple routers. So it is recommended that when the exit interface is an Ethernet network, okay, so that the static route includes a next hop address. You can also use a fully specified static route that includes both the exit interface and the next hop address. All right. Okay, so in a fully specified IPv6 route, both the exit interface and the next hop IPv6 address are specified. Okay, so there is a situation in IPv6 when a fully specified static route must be used. So if the IPv6 static route uses an IPv6 link local address as the next hop address, we use a fully specified static route. Okay, so the figure shows an example of a fully specified IPv6 static route using an IPv6 link local address as the next hop address. Now in the example, a fully specified static route is configured using a link local address of R2 as the next hop address. So notice that the iOS requires an exit interface be specified. Okay, so this is how we do it. Okay, so IPv6 route, right? Same command. This is our remote network. This would be your exit interface, and this would be your next hop IP address. So you specified both the exit interface and the next hop IP address. This is known as the fully specified static route. Okay, so the first one also, okay, so IP route, remote network, okay, this is your exit or the next hop IP address, right? So this is the traditional way of doing it, but with a fully specified, this is another option. Okay, now going back to the IPv4 here, how is it done? Same thing. So IP route, this would be our remote networks. All right, so with R1 being our source or the perspective of R1, you've got the subnet mask here. Okay, take a look at this. This would be your exit interface. All right, and you have here your next hop IP address. All right, so this is a fully specified static route. Okay, so the reason a fully specified static route must be used is because IPv6 link local address are not contained in the IPv6 routing table. Okay, so link local addresses are only unique on a given link or network. So the next hop link local address may be valid address on multiple networks connected to the router. So therefore, it is necessary that the exit interface be included. Okay? Now in here, the following example shows the IPv6 routing table entry for this route. So notice that both the next hop link local address and the exit interface are included. Okay, so this is your next hop address and this is your exit interface. So that means to reach 2001 DV8 ACAD1::/64, we can reach it via, okay, the next hop IP address here and the serial 010 here as the exit interface. All right, so that's it. Next, how do we verify a static route? So along with the show IP route, show IPv6 route, okay, ping, and trace route, other useful command to verify static routes also includes show IP route static. Okay, you also have the show IP route network, show running config, okay, pipeline section IP route, okay, and for IPv6, we just need to replace IP with IPv6, okay, and that will work the same. All right, so verifying a static route. So again, using the topology that we have earlier, okay, so display only IPv4 static route. So this output shows only the IPv4 static routes in the routing table. Also note where the filter begins the output, okay, excluding all the codes. So something like show IP route static, okay, pipeline begin gateway. So that means your output would start with your configuration gateway, right? And this would be the static routes configured. All right. Next, how about displaying a specific IPv4 network? So you can also do that. You can filter the output. Okay. So this command will show output for only the specified network in the routing table. So you specify the network to be 192.168.2.1. Okay. So that would be show IP route 192.168.2.1. So that would display routing entry for 2.0, and this is it. Okay. So known via static. The administrative distance is 1. Take note that the AD for the static route is 1 and the metric is 0. All right. Next, how about displaying the IPv4 static route configuration? Okay, section IP route here. So with this one, this command filters the running configuration for only IPv4 static routes. Okay. So show running config pipeline section IP route. So all configurations on the show run or on the running config having the IP route would be displayed. Okay, so rather than using just the show run, we displays everything. So if you just want to see on your screen a specific output that you desire, then you could make use of this filter options here, the pipeline section, begin, and so on. All right. Next, display only IPv6 static routes. So that would be show IPv6 route static. This output shows only the IPv6 static routes in the routing table. Also note where the filter begins the output, excluding all the codes. All right. So show IP route static. Next, how about displaying a specific IPv6 network? So for instance, show IPv6 route 2001 DB8 cafe :2::. So this command will show output for only those specified network in the routing table. Similar with that of IPv4 that we have presented earlier. Next would be displaying the IPv6 static route configuration. So something like section IPv6 route. So that would be displayed on your screen. So see, you have a filtered output for your show run commands. All right, so on this section, configure IP default static routes, we will be dealing how to configure a default static routes. Okay, so let's talk about default static route. This topic shows how to configure a default route for IPv4 and IPv6. So it also explains the situation in which a default route is a good choice. So a default route is a static route that matches all packets. So instead of routers storing routes for all the networks in the internet, they can store a single default route to represent any network that is not in the routing table. Okay, so take note that the default behavior of a router when it counters a packet not on the routing table is to drop the packet. Now, if you don't want to do that because you want these packets be forwarded to a certain destination, then we have to use a default route, which is also known as the gateway of last resort. All right. So routers commonly use default routes that are either configured locally or learned from other router using dynamic routing protocol. So a default route does not require any far left bits to match between the default route and the destination IP address. So the default route is used when no other routes in the routing table exist. Okay, so that matches the destination IP address of the packet. So in other words, if more specific match does exist or does not exist, then the default route is used as the gateway of last resort. Okay, so default static routes are commonly used when connecting an edge router to the service provider network or a stub router. So when you say stub router, okay, so this one here is a stub router. So a stub router is a router with only one upstream neighbor or neighboring router, so which is the ISP here. Okay, so the figure shows a typical default static route scenario. So R1 only needs to know about directly connected networks. For all the networks or for all other networks, it can use default static route pointing to R2 or to the ISP, for instance, in this case. Okay, so let's talk about the syntax, default static route syntax. So the command syntax for IPv4 default static route is similar to any other IPv4 static route, except that the network address is at 0.0.0.0, and the subnet mask is also 0.0.0.0. Okay, so the quad zeros here, right, quad zeros in the route will match any network address. Okay, so take note that an IPv4 default static route is commonly referred to as quad zero route. All right, so the basic syntax or the command syntax for an IPv4 default static route is IP route. You've got the quad zero, okay, quad zero, IP address, or the next hop IP address, or the exit interface. All right. Now for IPv6, we have the same. So the command syntax for IPv6 default route is similar to any other IPv6 static route, except that the IPv6 prefix or prefix length is : 0, which matches all routes. So the syntax would be IPv6 route : 0. You've got the next hop IP address, IPv6 address, or the exit interface. All right. Okay, so configure a default static route. So in figure 1, or in the figure here, okay, so our topology, so R1 could be configured with 3 static routes. 1 to reach each of the remote networks in the example topology, like what we did earlier. However, R1 is a stub router because it only has one connection, okay, or because it is only connected to R2. So therefore, it would be more efficient to configure a single route on this router. All right. So how do we configure this? Okay, so using the IPv4, again, the syntax would be IP route. You've got equal 0 followed by the next hop IP address. Okay, so which is, this is again your next hop. All right, so which is 172.16.2.2. So all traffic from R1 will be forwarded to 172.16.2.2. Okay, so same thing if we are going to configure R1 with IPv6 default route. So that would be IPv6 route : /0. Okay, so the next hop IP address, which is 2001 DB8 ACAD 2. All right, so that's configuring a default static route. Okay, so how would we verify the default static route? So we can use the command show IP route static. Okay, so the show IP route static command output from R1 displays the contents of the static routes in the routing table. So take note that you've got an asterisk there. All right, so the asterisk next to the route with code S. Okay, so the asterisk indicates that this is the static route, okay, and it's a candidate default route. So which is why it is selected as the gateway of last resort. So if you'll observe here, also you'll have here gateway of last resort, which is at 172.16.2.2, okay, to network any network. Okay, so notice that the static default route configuration uses the \0 mask for IPv4 default routes. So remember that IPv4 subnet mask in a routing table determines how many bits must match between the destination IP address of the packet and the route in the routing table. Okay, so the /0 mask indicates that none of the bits are required to match. As long as a more specific match does not exist, the default static route matches all packets. All right. Okay, so another thing is on IPv6. Okay, so the example shows the IPv6 or show IPv6 route static command. Okay, so to display the content of the routing table here. So again, we have here an S. Okay, so notice that the static default route configuration uses the : 0 prefix for IPv6 default route. All right. So remember that the IPv6 prefix length in the routing table determines how many bits must match between the destination IP address of the packet and the route in the routing table. So the : 0 prefix indicates that none of the bits are required to match. So as long as a more specific match does not exist, the default static route matches all packets. Okay? So other distinction than that of IPv4 is that we don't have an asterisk here on IPv6. All right? Okay, so on this section, okay, so configure a floating static route. What is a floating static route? Okay, so have you heard of this floating static route before? Okay, so as with the other topics in this module, you will learn how to configure an IPv4 and IPv6 floating static routes and when to use them. Okay, so another type of static route is the floating static route. Floating static routes are static routes that are used to provide a backup path to a primary static or dynamic route in the event of link failure. Okay, so the floating static route is only used when the primary route is not available. So to accomplish this, the floating static route is configured with a higher administrative distance than that of the primary route. So the administrative distance represents the level of trustworthiness, all right, we're talking about on the last topics. Okay, so if multiple paths to the destination exists, the router will choose the path with the lowest administrative distance. So for example, okay, So assume that the administrator wants to create a floating static route as a backup to an EIGRP learned route. So the floating static route must be configured with a higher administrative distance than that of EIGRP. So EIGRP has an administrative distance of 90. So if the floating static route is configured, okay, so with an administrative distance, say 95, okay, the dynamic route learned through EIGRP is preferred to the floating static route having 95 as administrative distance. So if the EIGRP learned route is lost, the floating static route is used in its place. So that is what we call backup. Okay? All right. So in the figure here, okay, so the branch router typically forwards all traffic to the headquarters router over a private WAN link. So in this example, the routers exchange route information using EIGRP. For instance, this one here uses EIGRP. All right. So this is the primary link. Okay. So a floating static route with an administrative distance of 91. Okay. So if this uses 90, okay, and we are going to assign here, for instance, the administrative distance of 91. So whenever this private one fails, all right, so therefore, the connection to the internet having the administrative of 91 will become inactive. Okay? So if the private WAN link fails and the EIGRP route disappears, for instance, from the routing table, the router selects the floating static route as the best path to reach the headquarters here. Okay? So that's when we use the floating static route. So if the primary thing or if the primary link fails, you've got the secondary link. Okay, so that will capture and continue the operation of the organization. All right, so again, that's how we use and when we use the floating static routes. Okay, so how about configuring IPv4 and IPv6 floating static route? So IP floating static routes are configured by using the distance argument to specify an administrative distance. So take note that earlier on the configuration of our static routes, we did not specify the administrative distance. All right. So if no administrative distance is configured, like what we have here, no? Right? So there would be no administrative distance configured there. That would be your primary link. Otherwise, if we have the administrative distance configured, that would be our floating static routes or the backup link. All right? So refer to the topology in the figure. The IP route and IPv6 route commands, okay, are issued on R1. Okay, so take note that this time our R1 is connected to R3 and R1 also is connected to R2. Okay, so R1 is configured with IPv4 and IPv6 default static routes pointing to R2. Because no administrative distance is configured, the default value is 1. All right, so take note that we have here, okay, we did not specify the administrative distance here, and the default value is 1. All right, that is for both IPv4 and IPv6. Okay, so R1 also configured with IPv4 and IPv6 floating static default routes pointing to R3. Okay, now take a look at the value of the administrative distance there. So you've got administrative distance of 5, okay, both for IPv4 and IPv6. This value is greater than the value of 1, and therefore this route floats and is not present in the routing table unless the preferred route fails. Alright, so the show IP route command, okay, and the show IPv6 route output verifies the default routes to R2 are installed in the routing table. So note that IPv4 floating static route to R3 is not present in the routing table. Okay, so you'll have it here. Okay, show IP route static. This is on R1. Okay, so something like it's via 172.16.2.2. Okay, so that means the active link is from R1, okay, going to R2, going to R3, going to, for instance, to PC3 here. But if this link fails, that should traverse, okay, so from R1 to R3. Take a look at also your next hop IP address on IPv6. That's 2001 DB8 ACAD, okay, so 2.2, which is also this one. So this is your primary link. Okay, so that is why we cannot see on the routing table, okay, so this link here, because this one is active. Now, if this goes down, all right, that's the time this will be going up, and you can see it on the routing table. All right. Okay, so we use the show run command to verify the floating static routes are in the configuration. Okay, so this would be our default or floating static routes. Okay, so shown in the configuration. All right, so for example, the following command output verifies that both IPv6 static default routes are in the running configuration. So again, since there is no indicated administrative distance here, this is our primary link or default. The default value is 1. And once this goes down, this would be our backup here. All right. Okay, so next, test the floating static route. How are we going to test it? So in the figure, what would happen if R2 fails? For instance, this R2 here goes down. What do you think will happen? Okay, so basically what will happen is this network here will not be able to reach other remote networks. All right. So without doing other things, okay, you could simply shut down, okay, R2, both of its serial interfaces. So that would simulate that the network is down. So R1 automatically generates a syslog message for the link going down, right? So a look at R1's routing table would show that the secondary route is being used. Okay, so assuming we have the link here. All right, so assuming that we have the link there. Okay. All right, so what would happen if R2 fails? This is basically what you see. Okay, so you're gonna have notifications that the interface and the protocol went down. So notice that R1 automatically generates messages indicating that the serial interface to R2 is down. Okay, so you'll have this. Okay, so a look at the IP routing tables for R1 verifies that the floating static route default routes are now installed as the default routes and are pointing to R3 as the next hop router. So you'll have it this time. Okay, so our backup path. All right, so that's how we test it. You could intentionally shut down the interface or your primary link and then see it on the routing table that it has changed to your floating static route. So next section would be configure static host routes. So this topic shows how to configure an IPv4 and IPv6 static route or host route, when to use them. A host route is an IPv4 address with a 32-bit mask, or an IPv6 address with 128-bit mask. So the following shows the three ways, okay, a host route can be added to the routing table. So first would be automatically installed when an IP address is configured on the router. Configured as a static host route, and host route automatically obtained through other methods, okay, so which will be discussed later in the courses. Okay, so automatically installed host routes. So Cisco IOS automatically installs a host route, also known as the local host route, denoted by L, all right, on the routing table. So when an interface address is configured on the router, the host route allows for a more efficient process for packets that are directed to the router itself, rather than for packet forwarding. So this is in addition to the connected route, designated with C in the routing table for the network address of the interface. So when an active interface on a router is configured with an IP address, a local host route is automatically added to the routing table. So the local routes are marked with letter L in the output of the routing table, like what you have seen earlier on the past demonstration or the past diagrams presented. All right. Okay, so for example, refer to the topology in the figure. The IP address assigned to branch serial 010, okay, are 198.51.100.1/30, and that would be 2001 DB8 ACAD 1, okay, ::1/64. Now, the local routes for the interface are installed by the iOS in the IPv4 and IPv6 routing tables. Okay? So it's in here. Right? So it's denoted by L. Okay? There. So the IP address assigned to the branch, okay, so take note, were indicated onto the routing table. So denoted here by letter L. Okay? Now, a host route can be manually configured with the static route to direct traffic to a specific destination device, such as the server shown in the figure here. The static route uses the destination IP address 255.255.255/32 mask. That would be for IPv4 host routes, and a /128 prefix length for the IPv6 host routes. Okay? So in here, if you'll observe, you've got IP route. That would be 209.165.200.238. Okay? 255.255.255.255. 198.51.100.2. Okay? So for IPv6, that would be IPv6 route 2001 DB8 ACAD 2. Okay? So ::238 2001 DB8 ACAD 1 ::2. All right. Okay, so how do we verify static host routes? So a review of both IPv4 and IPv6 route tables verifies that the routes are active. Okay, so it's in here. Okay. Now, for IPv6 static routes, the next hop address can be the linked local address of the adjacent router. However, you must specify an interface type and an interface number when using linked local address as the next hop, as shown in the example here. So first, the original IPv6 static host is removed. Okay? Then a fully specified route configured with IPv6 address of the server and the IPv6 link local address of the ISP router. All right? So that ends up this video lecture. Please see the video demo on how to configure IP static routing. Thank you very much. Thanks for watching and listening. Have a great day.